We're going to continue with our discussion on chapter 8. An ellipse is the set of all points in a plane, the sum of whose distance from two fixed points is constant. Each fixed point is called a focus of the ellipse. The graph of ellipse is not a function because it doesn't pass the vertical test. The foci lie on the major axis, the line from V to V prime, this point here to this V prime. And the minor axis in this case is from B to B prime. Let the foci of an ellipse be the point plus and minus C and 0. The sum of the distances from the foci to a point xy on the ellipse is 2a. And the rest of this derivations leads into the general equation of the ellipse. I will let you pause the session and take a look at this formula. You don't really have to drive this like we are having here, but the derivations are here. You can pause the session. For those of you like to drive this, you can see if you can do it on your own. Again, we were more concerned about the final results here, which is right here. As you can see, this would be the general equation of the ellipse at the end. That would be either x squared over a squared plus y squared over b squared equal to 1, or it could be x squared over b squared plus y squared over a squared equal to 1. As you can see, the bottom one is similarly, if the foci were on the y-axis, that would be this formula here. If the foci is on the x-axis, would be the one at the top. The ellipse with the center at the origin, that would be the equation. X squared over a squared plus y squared over b squared is equal to 1. When a is greater than b, and b is greater than 0, has a vertical, has vertices at point plus and minus a and 0. Endpoints of the minor axis would be 0 and plus and minus b, and the foci would be plus and minus c and 0, where c squared is equal to a squared minus b squared. For the ellipse, c squared is equal to a squared minus b squared. You're going to see this in a lot of the examples that you're going to look at, and that's the shape of the graph. Similarly, if the ellipse is open on the y-axis, the equation is given to us as x squared over a squared plus y squared over b squared equal to 1, where a is greater than b and b is greater than 0, has vertices 0 and plus and minus a, endpoints of the minor axis will be plus and minus b and 0, and the foci would be 0 and plus and minus c. Again, this is the formula that you want to pay attention to as well. C squared would be equal to a squared minus b squared, and that would be the shape of the ellipse that opens on the y-axis. Let's take a look at some examples now. Graph 4x squared plus 9y squared is equal to 36. Find the foci, give the domain and range. This doesn't look like a general equation of the ellipse. So what we need to do is to divide both sides by 36. Remember, the general equation of the ellipse should be equal to 1. So we need to divide each term by 36. Then we get it into the form of general equation of the ellipse. We have x squared over 9 plus y squared over 4 is equal to 1. So now I have all the information to graph this. The ellipse centered at the origin, there's no h and k here, has the x-intercept of plus and minus 3 and 0, and the y-intercept would be 0 and plus and minus 2. The domain then would be pretty clear. From negative 3 to 3, the range would be from negative 2 and 2. So the graph of the ellipse can be shown. Since 9 is greater than 4, so your a squared would be equal to 9. Remember, we said a is the larger one. So b squared would be equal to 4. C squared is equal to a squared minus b squared. So from there, we can solve for c. In this case, would be 9 minus 4 is equal to 5. C is equal to plus and minus square root of 5. The major axis is along the x-axis. So the foci has the coordinate of negative square root of 5 and 0 and positive square root of 5 and 0. And you can see that all that on the graph. The graph of the ellipse is not the graph of the function. Doesn't pass the vertical test. To graph an ellipse with a graphing calculator, solve for y. If you solve for y and plug that in your calculator, you can see half of the graph at the top, at the bottom, and it appears as whole would be the graph of the ellipse. graph 4x squared plus y squared equal to 64. Find the foci, give the domain and range. This would be a good place to pause the session, see if you can do this on your own now. Here we want to divide each term by 64 to get equal to 1. We want to get into the general equation of the ellipse. So there it is. This ellipse centered at the origin. X-intercept would be plus and minus 4 and 0. Y-intercept would be 0 and plus or minus 8. So the domain would be from -4 to 4, and the range would be from -8 to 8. And we can graph that easily. Since 64 is greater than 16, then your a squared would be equal to 64, your b squared would be equal to 16. You can solve for a and b, and c squared is equal to a squared minus b squared. You can solve for c, and c would be square root of 48, or we can reduce it to 4 radical 3. The major axis along the y-axis, the foci has coordinate of 0, plus and minus 4 radical 3, as you can see on the graph. Find the equation of the ellipse having the center at the origin, and foci is given to me as 0, plus and minus 3, and major axis of the length 8 units. Give the domain and range. If you recall, 2a is equal to 8. They're giving you a major axis is 8 units, so that would be equal to 2a. You can solve for a from here, that would be 4. If you remember, we have a squared minus b squared equal to c squared. So here the only unknown is b. You can solve for b. Foci lie on the y-axis, so the larger intercept a is used to find the denominator for y squared. The standard form is x squared over 7 plus y squared over 16 equal to 1. And you can see the domain would be from negative square root of 7 to square root of 7. And the range would be from -4 to 4. An ellipse center at h and k, and either a horizontal or vertical major axis satisfy one of the following equation, where a greater than b greater than 0, with c is greater than 0. For the ellipse, c squared would be equal to a squared minus b squared, and these would be the form when the parabola opens on x-axis or y-axis. The only difference from this one to the one with center at the origin would be we are going to add h and k here, so the center is not at the origin anymore. Let's take a look at this example. We're going to graph this ellipse and find the range and domain. This is already in the general form, so we can easily find the center, 2 and -1. Your h is 2, your k is -1. Since a is greater than b, a is equal to 4, is associated with the y square term. So the vertices are on the vertical line through the point 2 and -1. You can find the domain from -1 to 5, and the range would be from -5 to 3. And we can look at the graph. If you use our graphing calculator, when you solve for y, plug these numbers in your calculator, and you can see the graph, the top and bottom shape, and as a whole would be graph of your ellipse. Here would be a good example to do it on your own first. Again, you can pause the session and see if you can complete the square on both x and y to see it's going to be a graph of ellipse. As you can see, in first glance, we cannot really know whether this is the equation of the ellipse or the circle, but we know it's either ellipse or circle because both x and y are squared. If either one x or y were squared, then we could see that's a parabola, perhaps. But in this case, just by looking at this is either circle or ellipse. If I complete the square, then I would know. We've gone through complete square multiple times, so in this case, we're gonna gather all the x and y's and make sure we factor the coefficient of x squared and y squared, which in this case is 4 and 9, and we're going to find what we need to add. So if I take the coefficient of x divided by 2 and square it, and then do the same thing for y, you add inside the parentheses. Don't forget when you distribute this 4 and 9, that should affect the number that you added or subtracted inside the parentheses. Going to move that out, move it to the other side, and get it into the general form. As you can see, once we get to this point, divide each term by 36, we can see this is the general equation of the ellipse. So the center would be at 2 and -3, and the vertices would be 2 plus and minus 3 and -3. So it would be 5, -3, and -1 and -3. if a lithotripter is based on the ellipse, this is the equipment for kidney stone. It's given to us at x squared over 36 plus y squared over 27 is equal to 1. Determine how many units the kidney stone and the wave source must be placed from the center of the ellipse. The kidney stone and the source of the beam must be placed at the foci, which is C0 and negative C0. In this case, a squared is equal to 36, just by looking at the equation. B squared is equal to 27, and from there I can solve for C. Remember, we had for the ellipse, C squared is equal to A squared minus B squared, so C would be square root of A squared minus B squared. I have all the information to substitute to solve for C. So C in this case would be square root of 9, which is equal to 3. So the foci are at the point plus and minus 3 and 0. So the kidney stone and the source beam must be placed on a line 3 units from the center of the opposite side. And you can see it on the graph. A hyperbola is a set of all points in a plane such that the absolute value of the difference of the distance from the two fixed points is constant. The two fixed points are called the foci of the hyperbola. For the given figure, the center is the origin. The foci would be at plus and minus C and 0. The midpoint of the line segment F prime and F is the center of the hyperbola. The vertices are at the point plus and minus A and 0. The line segment V prime V is called the transverse axis. The hyperbola with the center at the origin equation is given to us as follows. As you can see, this formula is very similar to the ellipse. The only difference here is minus instead of plus. That's one observation. X squared over A squared minus Y squared over B squared equal to 1 has the vertices at plus and minus A and 0. The asymptotes would be equal to Y is equal to plus and minus B over AX. And the foci is at plus and minus C and 0. C squared is equal to A squared plus B squared. It's slightly different from the ellipse that we studied earlier. And that would be the shape of the graph. And if your hyperbola opens on the y-axis, you can see y would comes first, would be y squared over a squared. If I go back to the one that opened on x-axis, would be x squared over a squared. See the difference there? And the asymptotes are also given to us as y is equal to plus and minus a over bx. This was b over ax. So know the difference between the equation of the asymptotes if it's open on x-axis or y-axis. C squared would be equal to a squared plus b squared, and that would be the shape of the hyperbola. Let's take a look at the simple example of hyperbola. Here it's already given to us in that general form. So I can see my a is equal to 5, which is square root of 25. My b would be square root of 49, which is 7. So y would be equal to plus and minus b over ax, or plus and minus 7 over 5x would be my asymptotes. Choosing x equal to plus or minus 5 gives y is equal to plus or minus 7. These 4 points, 5, 7, negative 5, 7, 5, negative 7, and negative 5, negative 7 are the corner of the fundamental rectangle as shows in this graph. So basically to graph this, you would know the center is at 0, 0. So you start from this point right here, and you're going to move 5 units up or down and move 7 units where the B is, and this is the A, 5 and 7. So you're going to move 5 units on the x-axis, 5 to the right, 5 to the left, because this is 25. And then from the center, you're going to move square root of 49, which is 7 units up, 7 units down on the y-axis. Once I've done that, I can form this rectangle. And the diagonal of this rectangle would be my asymptotes. And my graph going to get closer and closer to this asymptotes. And the vertex would be right at the edge of these midpoints of this side of the rectangle. We know this hyperbola opens on the x-axis, so we're going to have our vertex right here, and then we can construct the graph. You can use our graphing calculator. If I solve for y, you can see you can construct the graph using the graphing calculator. You want to graph 25y squared minus 4x squared is equal to 9 and find the domain and range. Now would be a good time for everyone to pause the session and see if you can graph this on your own. This doesn't give it to me in the form of general equation. The first step is to make it in that form. Recall we need to this equal to 1. So I'm going to divide each term by 9. So we get in the form of 25y squared over 9 minus 4x squared over 9 equal to 1. And I know this is the hyperbola. If this were plus, then it would be a different story. It could be ellipse. So in this case, we want to determine the value of a and b. So I'm going to write in the general form. You remember general form was y squared over a number. So I'm going to move the 25 to the bottom of fraction. That becomes 9 over 25. And then move the 4 to the bottom of fraction and I get 9 over 4. This hyperbola is centered at the origin, has a foci on the y-axis, and has the interest of 0 plus or minus 3 over 5. We can do the same thing we did before. We're going to form the rectangle and draw the diagonal. We know this hyperbola opens on the y-axis, so this would be my vertices, and then this hyperbola would get closer and closer to these asymptotes. And as you can see, the range and domain, the domain would be all real numbers. However, the range would be from the negative infinity to this point here, minus 3/5, and from 3/5 all the way to positive infinity. The hyperbola with the center at h and k and either a horizontal or vertical transverse axis satisfy one of the following equation. C squared is equal to a squared plus b squared for the hyperbola, and these would be the general equation of hyperbola where the center is not at 0, 0 anymore. The center would be at h and k. And this simple example would demonstrate the graph of hyperbola, which is already given to us in that general form. This equation represents a hyperbola centered at -3 and 2. H and k is given to us right here. A is equal to 3, which is square root of 9. B is equal to 2, which is square root of 4. And we can construct a graph like we did before and find the domain and range as you can see on the graph. Write the equation of the hyperbola having the center at 1, 2. Focus is given to me as 6, 2. And the vertex is 4 and 2. Again, this would be a good time to pause the session, see if we can get started with this before we look at the solution. Because the center, focus, and vertex lies on the line y is equal to 2, the hyperbola has a horizontal transverse axis. The center is 1 and 2. So the standard form we know is y. The standard form of the equation is x minus 1 squared over a squared minus y minus 2 squared over b squared equal to 1. So we can substitute the values here. We know the values a and b. The distance from the focus to the center is 6 minus 1 is equal to 5. And the distance from the vertex is the center is 4 minus 1 is equal to 3. So c is equal to 5, a is equal to 3. The a squared plus b squared is equal to c squared. We can use that formula to find all these values. So b would be equal to 4. So we have our equation as follows. Write the equation standard form. Once again, this would be a good time to pause the session, see if you can complete the square like we did a few times already. We're going to gather all the x and y and find what we need to complete the square. We need to eliminate the coefficient of x squared and y squared by factoring that out. We're going to factor the 9 and -4. Take the coefficient of x divided by 2 and square it, and add that number to inside the parentheses. Again, don't forget that 9 and -4 need to be distributed into what you add inside the parentheses, and then move it to the right. And then you can divide each term by 36 to get into the form of hyperbola. So the center can be found by looking at this as 1 and -2. The vertices would be 1 plus or minus 2 and -2, which is 3 and -2, or -1 and -2.